The Basics of Counting, Section 6.1. Introduction. Combinatorics, the study of arrangements of objects, is an important part of discrete mathematics. Also, the enumeration, the counting of objects with certain properties, is an important part of combinatorics. We must count objects to solve many different types of problems. For instance, counting is used to determine the complexity of an algorithm. Counting is also required to determine whether there are enough telephone numbers or Internet protocol addresses to meet the demand. Recently, counting has played a key role in mathematical biology, especially in DNA sequencing. We can phrase many counting problems in terms of ordered arrangements of objects of a set with or without repetition, and these arrangements called permutation and combinations respectively. Basic counting principles. We first present two basic counting principles, the product and sum rule. Then we will show how they can be used to solve many different counting problems. Examples. Example 1. A new company with just 2 employees, Sanchez and Patel, rents a floor of a building with 12 offices. How many ways are there to assign different offices to these 2 employees? Solution. 2 employees consists of assigning an office to Sanchez, which can be done in 12 ways. For Patel, there is 11 ways to assign him an office. Total is equal to 12 times 11, 132 ways to assign offices. Example 2. The chairs of an auditorium are to be labeled with an upper-case English letter followed by a positive integer not exceeding 100. What is the largest number of chairs that can be labeled differently? So the total is equal to 100 ways times 26, that is equal to 2600 ways. Examples continued. Example 3. There are 32 microcomputers in a computer center. Each microcomputer has 24 ports. How many different ports to a computer in the center are there? So we have 32 computers, and then each computer has 24. So the total is equal to 32 times 24. That is equal to 768 ports. How many bit strings of length 7 are there? So like a bit, you have a 0 and 1. All right. So there is 2 ways of getting a bit, is either a 0 or 1. And then the lengths of all the bits are 7. So it's going to be 2 raised to the power of 7. How many different license plates can be made if each plate contains a sequence of 3 upper English letters followed by 3 digits? So the total is equal to 26 times 26 3 times 10 times 10 3 times. So that give you the 17,576,000. Examples continued. Example 6. Counting function. How many functions are there from a set with m elements to set with n elements? Solution: a function corresponds to a choice of one of the n elements in the codomain for each of the m elements in the domain. For example, there are 5 raised to power 3 different functions from a set with 3 elements to a set with 5 elements. Hence, we have n to the m. Examples continued. How many one-to-one functions are there from a set with m elements to one with n elements? First, note that if m is greater than n, there are no one-to-one functions from a set with m elements. However, if m is less or equal to n, there is n times n minus 1 times n minus 2 times n minus 3 times n minus m plus 1 ways. Examples continued. The student can choose a computer project from one of 3 lists. The 3 lists contain 23, 15, and 19 possible projects, respectively. No project is on more than one list. How many projects are there to choose from? Total is equal to 23 plus 15 plus 19. Many counting problems cannot be solved using just the sum rule or just the product rule. However, many complicated counting problems can be solved using both of these rules in combination. Example 7. Each user on a computer system has a password which is 6 to 8 character long, where each character is an uppercase or digit. Each password must contain at least one digit. How many possible passwords are there? Solution: let the total number of passwords be P. So let P6, P7, and P8 denote the number of possible passwords of length 6, 7, and 8 respectively. By the sum rule, the total number of passwords is equal to P6 plus P7 plus P8. So that is P6 is equal to 36 raised to the power of 6 minus 26 raised to the power of 6. And then P7 is equal to 36 raised to the power of 7 minus 27 raised to the power of 26 raised to the power of 7. P8 is equal to 36 raised to the power of 8 minus 26 raised to the power of 8. And then P total is equal to P6 plus P7 plus P8. Example 8. How many different ways are there to seat 4 people around a circular table where 2 seatings are considered the same when each person has the same left neighbor and the same right neighbor? Solution: we arbitrarily select a seat at the table and label it seat number 1. We number the rest of the seats in numerical order, proceeding clockwise around the table. And then we find the different ways of, so there are 4 pictorial ways to order the given 4 people for these seats. Because there are 4 ways to choose the person for seat 1, by the division rule, there are 24 divided by 4. There are 6 different seating arrangements of 4 people around the circular table. These are the references we used.